All right, this is video number 23. This is chapter 5, section 4. And this is all about properties of logs. And we're going to do all of these in log logs, but they work the same way for natural logs, the ln logs. Okay, so we have 3 different properties that you need to be aware of. The first is the product property. And it states the log base b of x times y is equal to the log base b of, oops, that's supposed to be an x, of x plus log base b of y. So you're just separating the multiplication into an addition problem with the same base. 2 is called the quotient property. And that looks like log base b of x over y is equal to the log base b of x minus log base b of y. And then 3 is the power property. And that looks like log base b of x raised to the r power. So the r comes down out front and becomes a coefficient or a multiplier on the log. So it's r log base b of x. All right, so using those properties, excuse me, Varsity actually kind of, it puts them in there and you just have to utilize the property to fill in some blanks. And we're going to go both ways. They're going to give you essentially this side at the beginning. Okay, and, oh no, I'm sorry, my bad, totally incorrect. They are going to give you this side, and you need to expand it into this side. And then I think we go the other way. Yep, we do. So you're going to start with yellow, go to green, then start with green, go to yellow, and then you're going to use the properties of logs to actually solve these things. So keep those handy for yourself. I'm going to actually do a dual screen so that we can see what's happening here as we go. Keep that on. That page. View. Pin it. All right, and then I'm going to add a page. Okay, so that's going to be over there on our right-hand side. I don't care where it is, just so as long as we can see it. All right, so here's a couple of examples for you. Number 1, rewrite. Log base 5 of 9x as log base 5 of a plus log base 5 of b. So your job, what you're going to see in that, you're going to see that in Varsity, and then they're going to have a equals a blank and b equals a blank. So you quite literally just have to fill in what a and b are, and those are the two things that are being multiplied, which are the 9x. So a is 9 and b is x. Okay? Fairly straightforward to pull out of there like that. The next one, rewrite log base 2 of 7 over x as log base 2 of a minus log base 2 of b. A equals and b equals. All right, again, a and b, looking back at the quotient property, your x is the top, y is the bottom. X is the top, which is a, and y is the bottom, which is x. Okay. Next one. I need to remind you, recall a to the m over n equals the nth root of a to the m. So the square root of 8 is 8 to the 1/2 power, right? You need to remember that kind of thing. Here's why. Rewrite log base 8 of the 4th root of x as a log 8 of b. Well, the first thing I would do if I was doing this is rewrite this with an exponent. So this is really log base 8 x to the 1/4. And now you have, if you take a look over at this screen over here, you now have x to some power or a base to some power, right? So the power ends up coming down out front. And so the power comes out here. So this is equal to 1/4 log base 8 of x. And so your answers are going to look like A is the 1/4 and B is x. So this is 1/4 and this is x. Okay? All right, let's take a look at a more complicated one. This one says rewrite log, and it doesn't have a base down there, but it's got x cubed y over the cube root of z. All right, so again, I'm going to rewrite as log x to the 3rd times y. So I know I have a product in there over z to the 1/3. So I have here's a product. Here's a quotient. And within that quotient is a power. So I kind of have all of these. So let's just deal with the top, the product property. That's going to give me log x cubed plus log y. And then the quotient is a minus log z to the 1/3. Well, now I'm going to have to deal with my two powers. So I've got a power here and a power here. And so this guy will come out front. This guy will come out front. So I have 3 log x plus log y minus 1/3 log z. And the way this looked in varsity was rewrite it as a log b plus c log d minus e log f. So if you don't get it into that form, you've made an error. But we could now easily fill in if we have a is, b is, c is, d is, e is, and f is. Well, a is 3, b is x, c is, there is no value there, so put a 1 in, d is y, e is 1/3, and f is z. Okay? So that's how you're going to handle those guys if you see that kind of stuff going forward. All right, now let's go the other way. We'll do a new page. And you have 5 log base b of x minus 3 log base b of y. And you're asked to combine these. So the first thing I would do, you see these coefficients out here, bring these up and write these as powers. So now you're going the other direction. So I have log base b of x to the 5th minus log base b of y to the 3rd. And now you know the quotient means divide. So now I have log base b of x to the 5th over y to the 3rd. And I don't remember how varsity wanted you to put these in. I think you had to put this whole thing in just like that, like simplify it and actually write the answer like that in varsity. All right. This one was interesting. How about log? Oh, that's an x. Let me redo that. All right. Let me get a different color pen also. So let's go log x to the 1/2 minus log y to the fourth minus log z to the second. All right, well, we'll take these first two and deal with them first. So that means division, right? So I have log x to the 1/2 over y to the fourth. And then if I divide again, I have z to the second, and that would be over 1. So make sure you do a keep change flip. So this will be 1 over z squared. So, and to get rid of you can't have a fraction in a fraction, right? You got to simplify that. We learned that when we did our rational expressions. So now I have log of x to the 1/2 over y to the fourth z squared. And that's how that answer would look. All right, now let's solve two of them utilizing this information. So we're going to solve, let's see, log base 4 of x minus log base 4 of 5 equals 2. So first, rewrite. So you have one log equation or one log statement, and we know that this is division. Bases are the same, right? So they have to be to do this. So we have log base 4 of x over 5 equals 2. Well, now you know from the definition of logs that 4 to the second equals that. Well, 4 to the second is 16. And this is really over 1, so now you can cross multiply. 16 times 5 equals x times 1, which we don't need the times 1, and 16 times 5 is 80. And that's the answer to that guy. All right. Similarly, let's get rid of that one. We'll get a whole page for ourselves. We're going to solve log base 6 of x plus, oops, get back there. Do I have a pen? Of x plus 40 minus log base 6 of x plus 5 equals 1. Okay, so rewrite first. So we have log base 6 x plus 40 over x plus 5 equals 1. And now I can say x to the first equals x plus 40 over x plus 5. Well, x to the first is just, or 6 to the first, sorry, is just 6. And this is really over 1. Now I can cross multiply. So 6 times that equals 1 times that. Right? When you cross multiply, you get yourself an equation, which not the strongest suit for some of you. So this is 6x plus 30 equals x plus 40. I'm going to subtract off an x, subtract off an x, subtract off 30, subtract off 30. Cancel, cancel. 5x equals 10, x equals 2. Okay? So what that means, you could check this, by the way. The original, woo, look at that. It's crazy when that happens. Okay, so the original was log base 6 of x plus 40 minus log base 6 of x plus 5. We're saying that equals 1. So when we rewrote this, we can put the 2 in right off the bat. So we have log base 6 of 42 over 7 equals 1. Well, 42 over 7 is 6. So log base 6 of 6 equals 1, and then 6 to the first equals 6, and that checks. So you can feel free to do that for yourself. All right, so that's properties of logs. It's fairly straightforward, and it's something that I've seen a bunch of times actually on the ACT test. So you might need to use that in the future. All right, toodaloo for now. One more section, I think, to go.